Hey guys, let's talk about new problem from dynamic programming, which is called climbing stairs. Okay, so you're climbing a staircase with n steps. Okay, you can climb one step, two step. So to find the total number of distinct ways to reach to the top. So for example, if let's say you're at zeroth stairs, okay, and then this is first stair, this is second stair, this is third stair, okay, and now you can climb at a time either one step or two steps, okay, no three steps. So now if you wanted to reach till one, how many ways you can reach? By one way only, one step, correct? And if I talk to you, if I ask you to second step, so either you can take one step two times, okay, one and then one, otherwise directly jump to one, two, right? So two ways, okay. For 2 it is 2 ways. So this one will be your base condition. When n is equal to 1, return 1, n equal to 2, return 2, n equal to 0, then return 0, right? Because you will not take any stairs. Now if I ask you for n, so how many stairs will be there, how many ways will be there? So see, I can take either 2 step or 1 step. So if I go to 1 step back, okay, means n minus 1, and 2 step back means n minus 2. So if I'm able to find the ways for n minus 2 and for n minus 1, I can do summation for them, right? And then I can find for n, correct? So so let's take one example. So if n equal to 5, okay, so you can either take 5 times 1 or 3 times 1 and 1 times 2, and similarly you have different 8 ways, okay. And what will be the base cases? If f of 1 is 1, then return 1, f of 2 is 2, return 2, right? So now if you try to solve this problem using recursion, so what will be your answer? See, it will be ditto same problem like Fibonacci series, okay. So if you take top to bottom approach, okay, using recursion, so this one will be your solution. So climbing stairs n equal, so if n, this is your base condition, if n is less than equal to 2, then return n, otherwise find value for climb stair n minus 1 and the n minus 2, and then do summation for that. So it's a time complexity will be 2 to the power n, okay. Every time you have a 2 possibilities and n times, right? So, and here you are repeating, you have the problem of repeating calculation, what we discussed in the Fibonacci series video lecture, right? Just before this video lecture I have uploaded that. So now we have another solution which is called bottom up approach and dynamic programming tabulation approach. So instead of calculating that function again and again, you will calculate it once and then store its value in a DP array, okay. So here the solution will change something like this. If n is less than equal to 2, return n, base condition, otherwise create one DP array, okay, DP array of size n plus 1, okay, because we are starting from 0th location, 0th index. So dp1 1, dp2 2, so this one 1 2, this one will be your base conditions, okay, 1 2, and then if it is 0, then here this one will be 0. Now for I equal to 3 to I equal to I is less than equal to n, you run one for loop and then find the value of something like this, dp3 equal to dp2 plus dp1, right? You have dp2 value, which is 2 plus 1 3. So now here you're going from bottom up, right? That's why this is bottom up approach, and something like this you will go till n and return the dpn value, okay. This one will be solution. So here your time complexity will be order n, but space complexity is order n you're using for this DP array. So can I reduce the space complexity here? Yes, I can use that space optimization, okay. So I'll take 2 variables, previous 1, previous 2, and then instead of storing value in an array, I will store in previous 1, previous 2, right? Because at the end I required only last 2 values and not the entire array value, right? That's why I have replaced it. So now this time my time complexity will be order n and my space complexity will be order 1. And I have explained all these things in detail in my first video, which was related to Fibonacci series, Fibonacci number in dynamic programming. So that's it. Thank you.